Okay, in this problem, we have a 5.2 kilogram block that is stacked on top of a 10 kilogram block, and we are going to pull it with a horizontal force of 45 newtons. And the coefficient of, 5.2 kilogram block is attached to the wall. All right, so we need to put a wall in here. So we'll make this look like a wall. And just for the sake of my discussion right now, when I attach this to the string to the wall, I'm going to make my string a little bit slack. Okay, just a little slack right now. All right, the coefficient of friction between all surfaces is 0.18. 0.188. All right, so they said coefficient of friction between all surfaces. So we're going to figure out what the friction is right down here. So friction is going to be mu mg. So that's going to be 0.188. The mass would be like the mass of everything here. So that would be 15.2 times 9.8. And so that turns out to be, on the bottom here, 28 newtons. A perfect 28 newtons. All right, but there's also friction between these two blocks here, because when I pull on this 10, it's going to slide a little bit, just a teeny bit. And it's going to slide because this 5.2 guy is stuck to the wall. And when I pull on the 4.5, if you could picture, the 5.2 guy is going to move ahead a little bit like this, like he's going to kind of follow the 10. But that string is going to become slack. And so when the string the string is going to become taut. And so when the string becomes taut and the 5.2 is moving along with the 10, that tells me that the friction has to be pointing backwards, because it has to be opposite the direction that the 5.2 is going to move. So you have to understand that the 5.2 is going to move just for a short period of time on top of the 10 as the 10 moves forward. So there's friction now up here. So this is going to be mu mg. But this friction is created just by this 5.2 block, because like you could pretend that the 10 and that was part of the table. So this is 0.188. The mass of the block sitting on the 10 table. So the mass of the block is 5.2 times 9.8, and we find out that the friction up here is 9.58 newtons. All right, question A says determine the acceleration of the 10 kilogram block. So basically they want me to draw like a free body diagram of just the 10. So if I redrew that down here of just the 10, we would see that we have the 45 going forward, and we have two friction arrows going backwards. We have the friction arrow up here, and we have the friction arrow down here. So this one is 28, this one is 9.58. And so we can find the acceleration by just doing F net equals ma. And we have a 45 that we're pulling minus friction 1 minus friction 2 equals m times a. And we find out that the acceleration is, I don't know because I didn't do that, 0.724, so says the worksheet. Okay. Then the last question, or the next question, letter B, says determine the tension in the string. So as you pull on this 45 and you pull the 10 block forward and the 5.2 block ekes forward a little bit, this slack string is going to become taut. And the only force that's in this story, the only force that could possibly be in the story, is this little friction arrow down here. So whatever this friction arrow is, 9.58, this 9.58 then becomes the tension in the string in that picture.